Welcome to this lecture where we will discuss different approaches and methods to assess the social impacts of our process designs. Once the conceptual process design, technical feasibility analysis, economic evaluation, and environmental impacts assessment are completed, we can move ahead with the social impact analysis to gain a broader understanding of the potential consequences of our process design and related value chain. The social impact analysis is an optional step. However, I strongly believe that we, as process designers, should be aware and concerned about these potential social impacts. As mentioned in the introductory lecture, industrial biotechnological processes are not isolated entities. They exist within a complex and context-dependent supply chain where multiple actors with specific interests and responsibilities are involved, which is in line with the concept of socio-technical systems. All of those stakeholders will be impacted in different ways and at different levels in the three dimensions of sustainability, and therefore they should be included in the decision-making process, meaning that their goals and concerns should also be considered. Let's, for example, take a look at the concept of biohubs. A biohub, within the context of industrial biotechnology or bioeconomy, refers to the coordination of stakeholders to achieve regional socioeconomic development, conservation of natural resources, and efficient use of infrastructure and capital goods while adding value to those resources through the production of marketable products. However, given the high complexity of those socio-technical systems, there are inherent social concerns related to the different stages of the production chain. For example, in the case of feedstocks production and land management, stakeholders may wonder if the biohub could lead to, for example, an increase on local employment, better working conditions, or income levels. But they may also wonder if food prices, land availability, soil quality, and biodiversity could negatively be affected. Or stakeholders could be more interested in social acceptance, policy support, or fair distribution of responsibilities and benefits along the value chain. To understand these potential social impacts, we can apply two main perspectives. One centered on stakeholders and the other one centered on the production chain. In the former, the social life cycle assessment and participatory methods could be used. In the latter, quantitative macroeconomic approaches and standard certification schemes could be applied. Let's take a look at what they actually are. The social LCA is a relatively new method that aims to assess the actual or potential social and socioeconomic impacts directly caused on stakeholders, which could be positive or negative in relation to the production of a specific product. This method follows the life cycle thinking, which considers the potential impacts along the entire life cycle activities, covering from the extraction of raw materials to the final use and disposal of products. To do so, the United Nations Environment Programme and the Society of Environmental Toxicology and Chemistry developed the guidelines for social LCA. They divided the stakeholders in 5 different categories, where multiple impact categories can be considered per stakeholder category, and in a similar way, several impact subcategories and indicators can be considered. However, the applicability of such subcategories and indicators would depend on the data needs and availability. For example, some typical impact subcategories are shown in the slide, but the final selection of suitable impact indicators would indeed be limited by access to data and information related to those specific indicators, which are both case and context dependent. But this selection is not limited to the list of subcategories and indicators available in the guidelines for the social LCA. We could also use other sets of subcategories and indicators reported in literature, which could have been developed for specific products or sectors, like the framework shown in the slide for bio-based supply chains. However, in case we want to apply the social LCA method, we should make sure that the selected subcategories and indicators are in line with the goal and scope definition of our analysis. An alternative for social impact analysis is to work directly with stakeholders to identify the impact subcategories and indicators that the different groups would recommend to be included in the analysis. This approach can help to have a broader coverage of stakeholders' concerns and expectations with the new production chain. This approach has, for example, been used to select impact subcategories, indicators, and datasets for social impact analysis of different technologies and value chains for sustainable aviation biofuel, where different selection criteria have been considered like relevance and simplicity for indicators and data. In this way, a set of indicators like the ones underlined in the table can be selected based on the inputs from the different stakeholders groups. Now, in the case of approaches considering the production chain perspective, we can apply quantitative macroeconomic methods like the input-output analysis. The core of the input-output models is the inter-industry monetary flows from each economy sector to all the other sectors, and this could be done at the national or regional levels. This matrix captures the direct and indirect interdependencies of the different economy sectors, and for these reasons, this technique can be used to evaluate the macroeconomic effects resulting from a market shock in the economy of a country, like for example, a larger market demand, a new product, or a new supply chain. Such macroeconomic effects can be estimated as specific socioeconomic indicators like creation of total jobs, generation of gross domestic product, and the net trade balance, which is the difference between the imports and the exports. The input-output matrix can be adjusted to account for the market shocks in two different ways: by considering the specific monetary changes by pairs of economy sectors, or by adding a new economy sector which could be related to the new supply chain. Let's check this approach using, as example, the production of sustainable aviation biofuel in Brazil, which can be considered as a new sector in the input-output matrix. In this case, three combinations of feedstocks and technologies are considered as suitable options for SAF production in Brazil, and we are interested in the macroeconomic effects of the three indicators that I just mentioned. For the market shock, 4 different scenarios for SAF demand in 2050 are considered. In the purple boxes, you can see the combination of feedstocks and technologies for the 4 demand scenarios, which are in the green boxes. In this case, results are shown for total employment as indicated in the blue light box, and the total jobs created are shown for each economy sector depending on the feedstock, technology, and demand scenarios. As suggested for the technical, economic, and environmental analysis, it is again recommended to include sensitivity scenarios or uncertainty analysis to gain a deeper understanding of the potential socioeconomic impacts that could result from the large-scale implementation of our designs and supply chains. Similar analysis and trends can be done for the other macroeconomic indicators. Finally, certification schemes can also be used to assess social impacts, especially for supply chains that already exist or that are close to implementation, but not so much for prospective analysis. These certifications are often sector or product specific, and they usually consider a static list of social subcategories and indicators. So they are less flexible than the other options discussed in this lecture, but at the same time, they could be more consistent in terms of methods, data, and information used, which make them useful for comparative analysis. But in general, some subcategories are consistently included in most of the certification schemes, like for example, working conditions, employment, and human health and safety. We now have some more tools to do an integral sustainability assessment, which is the topic for the next lecture. See you then, and thank you for your attention.